So I ran this test case over the last month on Summit. So I was testing out CGNS with HDF5 and I've presented results before, but then this is for running from no local storage to GPFS on Summit. And for this case, I did 5 output dumps per at each rank setting. And I did weak scaling. So you can see the number of ranks. I went from 11 gigabytes and then the largest I ran was 43,000. Somehow I miscalculated the number of elements and I went from 211 to 1.7 terabytes for the largest one. So I have to keep that in mind. So the first case is doing from no local storage. So what that means is on Summit, you can write to the no local, well, it's a storage that's actually on the node and you just give it a path. So in Subfiling, you can set you can set the prefix for the subfiles. And if you set that to be, and if you set the path to be to the no local storage, then it'll write on that. Another thing you have to keep in mind when you do no local storage is that those files are only seeable on that node. So say, for example, if you're running your CGNS application and you're writing to the subfiles to a node, for example, one node or one subfile per node, that if you want to then process those files again, you have to submit a new job with what I've been doing is setting it so it runs one process per node and then spreads out over all the nodes so that you can process those files. So you'll be able to see those files when you run that second job to join those. I've been joining those files back together, these subfiles, to make a valid CGNS file. So now I have both. I've presented both before on the smaller scales, the write performance, and now I have results for read performance. So this benchmark in CGNS, it writes the nodal coordinates, the connectivity array. I also have some field arrays that I'm writing and some other arrays that arrays that you make up yourself. So that it also, what it does is it writes it and then it reads it back. So when it reads back, I'm not converting it to an HDF file. I'm reading it back as subfiles. So you can see this. So the time is on the Y and the number of ranks. And the blue is the write. So it goes, again, it shoots up around at 43,000 ranks. But the read is very consistently very good. So it takes hardly any time to read those files back in from node local storage. And I think this is almost half the machine. So it's a pretty big problem. So now if you want to put the files back together, so there's a tool that we call H5 Fuse. What it does is you would submit that as a second job. So you would do whatever MPI exact, the number of, well, on Summit it's JS run, and you'd specify that you only want to run one process per node. And for this example, so if you have 134 nodes, I think that's 32. That's 134 or 1,344 ranks. That's 32 nodes if you're running 42 ranks per node. So you'd specify I'm going to run 32 processes and then spread out, but only run one per node, run one process per node. And so that what we'll do is take the fuse files that are on the node local storage and then transfer it over to Summit's GPFS storage system. So I write this to one single shared file on GPFS by putting those together. And it uses a DD essentially to combine all those files together. And you can kind of see the performance. There's some outliers here. And on 43, it took around average 18 seconds to put the 1.7 terabyte file back to copy it from no local storage back to the GPFS file system. So that's still pretty good. And usually I haven't tried yet that I'm working on where you can call it from the program and then execute that in the background as a separate. So start a thread and then execute that fuse to run in the background and then write that to the GPFS file system from within the application. So you should be able to hide a lot of this movement from the no local storage to GPFS storage in the background. And that's pretty much all I have for the results with subfiling. I'm currently working on, right now I'm controlling the subfiling parameters through environment variables, but there's some applications that you want to use it. You want to configure that from, when you call the subfiling VFD, you can give it a struct that gives that you can control the parameters instead of through the struct parameters instead of through the environment variable. So I'm going to add that to CGNS as well. And there's a couple other applications that also use subfiling that I will add that feature to. That way you can call that within your application, the fuse, at least especially like the fuse. You can call that within the application as well. Any questions about that?
Can you go back to slide number 3? I mean, yeah, I mean, great, interesting numbers. And is this the similarity for writes between slides 3 and 4? Is this just a coincidence, or what?
Yeah,
what's going on?
Just a coincidence, because this is just from no local, so that it never goes to GPFS in this case.
Yeah, but then what explains the
bump here?
Yeah.
Well, I mean, we're writing more data here, right? It's if this was 211 gigabytes, where this is 0.7 terabytes. So this is a lot more data. I tried to scale it up. It should have been somewhere around here probably, but.
And there is, I mean, from the subfiling side, there is no, I mean, there is probably a low level of inter-process communication going on, but nothing major.
No, especially if it's going to no local storage, there shouldn't be any contention between the nodes. I mean, there's no file locking. I think I think there might be a broadcast, though, a couple broadcasts that maybe might be slowing things down.
Yeah. And so what was the ratio between the sizing here? So okay, 211. So a factor of what? 8, 9. Yeah. Okay. Well, that
It could be. I mean, you gotta take that with a grain of salt because that's with alignment. So some of those it's kind of empty. So it's really not writing. It's probably not writing that much data. I have to look to see how much it's actually writing because it might be padded. Since the best performance is aligned with alignment. So if you set the subfiling stripes, what we call stripe size, the same as the alignment, you get the best performance. So it's always good to set the alignment.
And then on sort of slide number 4 or 5, no, there weren't 5 slides, 4, right here.
There is some, I mean, this is, there was one outlier, I cut it off, but it was at 300 seconds to do one of the fusions. And I mean, this does take into account if people are clobbering the system. I mean, this was almost the whole system, right? So if someone's doing something else,
Right.
this
Yeah.
this can get interfered with other users. That's probably why
Mm-hmm.
there's differences here.
Mm-hmm. And this is fundamentally limited only by the interconnect, because from an HDF perspective, it's really just allocating a gigantic file and then individual ranks reserving chunks of that file and basically copying the data. And so
Right, but it's not using HDF5 at all. It's
right. Yeah.
Mhm.
Mm-hmm. Yeah, and that's contention on the network or whatever. Yeah.
Well, if you have other people writing to the GPFS storage system, that can, especially at this scale,
Mm-hmm. Mm-hmm.
it seems very sensitive whether users are doing it when you're using a lot of the machine.
Right. And what's the relationship between ranks and nodes here? Sort of how many nodes did you have for these rank counts?
Let me see. It went up to 1,024. Is this 1,024 nodes was the largest. I'm running 42 ranks per node.
Okay. Uh-huh.
And I think the full machine is 2,048. I have to look it up, but I think it was half. That's half the machine. It's expensive to run it, so I didn't run the whole. I don't think I could even run. It'd probably wait forever to run the whole machine.
Yeah.
But this is the largest I've ever run. I mean, this is. I've never run CGNS with this large and get this. I mean, I didn't run the single shared file to compare just because it takes. Yeah.
Mm-hmm.
I didn't want to use up a lot of allocation.
Right. Yeah. No, that's great. I mean, and if you look at the cumulative time, so you basically put slides 3 and 4 together, that's reasonable
Yes,
as
it's
far as
reasonable.
timing goes.
It's less than a minute to write and full 1.7 terabytes.
That's
pretty good. Mm-hmm.
Does the subfiling write a file per rank or a file per node?
File per node. And you can write more than one subfile per node, but you have to write at least one per node. If you wanted to, you could, which would probably be really terrible. You could write all a subfile or each rank on a node, which would be essentially a file per process. But I don't think it would be, I haven't done that, but it'd be a lot. I think you'd add a lot of communication within subfiling itself if you do that.
Right.
Yeah, and I still have, so I did like to study the effect of using more than one subfile per node. Usually the best performance seems to trend towards using less subfiles per node as opposed to more.
So from the CGNS side, it looks like it thinks that it's creating a single shared file, but then the subfiling VFD takes care of splitting it node to node to node.
Correct. Mm-hmm.
Okay.
Yeah, even right now, all you have to do is set the environment variables to trigger. Well, you have to have the subfiling feature that it calls the file driver, but you can control that by environment variables. And then it will just, it will create all those subfiles for you automatically.
Mm-hmm.
Yeah, it'd be interesting if people get a chance to try out subfiling. Would like feedback on what other people are. We also are working with another application that I've been using subfiling, and it's getting also very good results. But we still have to run on Lester as well to see if it gets similar results.
Mm-hmm. From a usability point of view, is there something that, okay, I mean, for people who use these types of systems, I guess it's not asking too much to sort of add an extra line to the batch script to then fuse the subfiles together. Nevertheless, from a usability point of view, is there something that we could do to, yeah, make it even more transparent or more user-friendly in the sense that, yeah, we don't have to ask people to then do the fuse by hand, so to speak?
Well, possibly you could use it with the cache fall. If you kind of with the cache fall manages memory. Well, it manages automatically within HDF5 library, no local storage, and then pushing it to the GPFS. So if you went that route, you could do. I'm not sure how subfiling will work with the vol, if it would be compatible with the cache vol currently. But that's how you would do it. You would use probably the cache vol to be able to manage the movement from no local storage to regular storage. I guess you could also use it for if you're writing directly, you don't have to use no local storage. You could write directly to GPFS, and then you could, I guess, use that tool to fuse the files back together through HDF5.
Is there actually a tool that is, so to speak, the opposite of
splitting it?
Yeah.
Yeah, we mentioned that last time. Not yet. No.
Not yet. Because in a way, I mean, wouldn't that be almost, although on a much, much bigger scale, sort of the convergence of paged allocation and subfiling, so to speak? It's in a way you're just approaching more or less the same thing from different angles.
Right. But the thing you'd still have to submit a job to break that. Well, would you? Well, I guess you could do it serially to break your single HDF5 file into subfiles. But if you want to do local storage, then you'd have to submit a job to copy those. I guess you wouldn't need to copy them. Yeah, it'd be page allocation, and you but you still have to pre-process that data.
Right. In a way, I mean, let's say you can think about, okay, use cases for subfiling, and I'm sure there are plenty of use cases, but for example, an obvious one, checkpointing. Now, of course, for checkpointing, the problem, well, not the problem, but one issue with subfiling would be you're restarting with a different number of nodes or ranks, not so much nodes necessarily, ranks. And so if you hadn't fused the subfiles, but somehow, because I don't know, we would have to benchmark that for staging, if there is an advantage of staging subfiles rather than splitting something and then staging sort of these fragments. But then it's in a way, if you if you over divided the subfiles, so to speak, to buy yourself that extra space that you could potentially restart with a different rank count and make it sort of more compatible with the subfile layout, so to speak. That I mean, as an HDF5 file, of course, the beauty is you can restart with any number of ranks. It doesn't matter. An HDF5 file is an HDF5 file.
Well, you can restart with any number of ranks with subfiling.
Pardon me?
You can restart with, if you have subfiles and you start with that you have for a certain number of nodes, you can restart with different
right
nodes. You can still do that with subfiling.
Right. But there might be a performance
Yes, there would be,
difference.
yeah, there would be a performance difference because some
Yeah.
nodes then would have to read into another file, right?
Yeah.
So yeah, you could be opening up multiple files at a time. Yeah,
Yeah.
there would be performance hit.
Yeah. It's just something to think about. From a usability point of view, if there's something we can do, because from a performance point of view, it's obviously it's a great story. It's yeah.
Mm-hmm. Yeah, Greg, if you have an opportunity to try it out, it'd be great. If you have an application or machine that you want to try it, just let me know.
Okay, yeah, I probably will. Yeah, if you could just send me like a summary of how to set it up.
Mm-hmm. Yeah, I'll do a forum post on CGNS at least as once I get it, and then how to set it up. I should, as soon as I get the struct in, where you can call it from the API, then I'll move it, develop, and release the next version of CGNS.
Okay.
I think Joe posted a question here in the chat. He wanted to know, is there any other CGNS IO software packages to compare subfiling performance?
Well, do you mean, I mean, there's other, I can run it with just a shared file, and I can run it, if that's what you mean, to compare it to
No,
that.
I think Joe means maybe an altogether different application.
Yeah, I have different, last time I showed Cabana, which is a particle application. And then we also tested it with IOR and the H5 bench, which is it's a benchmarking from the HPC IO team. And that uses many different ones. Yeah, we have other
How
subfiling.
about the ADF? Is it really bad in CGNS world?
What is it? Sorry.
ADF?
ADF.
Yeah.
That's the that doesn't do parallel. You can't do parallel with the original ADF format.
What is ADF?
ADF was the original before they switched over to HDF5. That was their original format.
Oh, okay.
It's similar to what Silo also has its own format before. You can either switch between the original and then HDF5. It's similar. Any other HPC general questions or?
Who's up next? Who is next week?
I think it starts over again. Is it Dana?
Yeah, if it's already the first, it'll be Dana next week.
Okay.
So I have another question. So in CGNS community, don't they migrate to cloud as a storage and things like that? Yeah.
No, there's no cloud initiative right now.
So nobody uses a cloud-based database as a CGNS output.
No.
No. Oh.
Partly because there's no functionality in CGNS for that right now.
Interesting.
There's nothing to say since I mean, it supports HDF5, so if HDF5 would support it, then CGNS would inherit it. It just hasn't been tested or exercised or anything.
All right, we can wrap up. We're just a few minutes early. And I think we're working on a 14.1 release very soon. And that may be something Dana will talk about next week. But otherwise, we'll see everyone back here then. Thanks, everyone.
Yeah, there's been a lot of changes for the subfiling. There's a lot of bugs. So yeah, 1.14.1 should help improve some of the subfiling features, especially like if the fuse tool also was improved, so better performance. So yeah, 1.14.1, if you want to try subfiling, is probably the version to use when it comes out. Okay, that's all I had.
Thanks, Scott. All right, bye, everyone.
Bye.
Bye.